the mascot of the compiler is actually usually is a dragon because it tells people that building a compiler is like killing a dragon. It's not trivial work. So yeah, it's pretty nice. So today, when we are talking about EVM LLVM project, what we are talking about, we're going to talk about what it is and then the impact that it may have to the Ethereum community. And of course, some engineering details. And if time permitted, I'm going to do a little bit code to let everybody have a sneak peek on the project. Okay, so EVM LLVM, what it is. Okay, you see that there's two VMs there. So perhaps it's another VM running on the blockchain. Actually, EVM LLVM is a new LLVM-based compiler backend targeting the EVM architecture. LLVM is basically a compiler framework. So the EVM LLVM is basically a new backend created on it targeting the EVM architecture. But some people would be also wondering, well, what is LLVM? Well, LLVM is actually been around for almost 20 years, and it's one of the, perhaps one of the most exceptional open source software projects that has very quality code base, and it is widely being used in the industry. So LLVM is actually a retargetable multiple source compiler framework. So let's say you have a lot of programming languages, and then you have a lot of LLVM front ends, and then the LLVM kind of like convert everything into an LLVM internal representation, and use the common infrastructure to generate different code to different architecture, like x86. PowerPC, ARM, for example. Today, LLVM has become the umbrella name of the LLVM project, which has a lot of components built around it. So at the core of the LLVM infrastructure, let's see the LLVM IR. So the LLVM IR is the internal representation of the compiler. So you have a lot of the front-end programming languages. And those programming languages will be lowered by their specific front end into LLVM IR. And on the LLVM IR, we basically have a lot of LLVM passes, which you kind of analyze it, optimize it, transform the LLVM IR, and verify them. And eventually, when everything's ready, you lower it again into your architecture-specific binary codes or assembly codes. Today, actually, LLVM has grown pretty big. So you can see that a lot of the programming languages today are actually utilizing the LLVM infrastructure as their compiler framework. While LLVM IR is basically a pretty low-level code generator, and for those like really high-level programming languages, like Swift, Rust, and Julia, for example, or even TensorFlow, they have their own high-level IR that can do their programming language-specific optimizations on it. And after their programming language-specific optimization has been done, they are being lowered to LLVM IR, where they translate the IR into their machine code. So LLVM now is pretty big. It has a huge ecosystem, and we want to bring the ecosystem to the blockchain world. I think this is one of the early tries that we do this. So what does Ethereum family, why does Ethereum family need LLVM today? Because if you take a look at the comparison chart here, it tries to compare the different runtime systems, EVM, WAS, and JVM. You can see that EVM is pretty high has a pretty high rating on the security and deterministic, but it's pretty low on the support of the languages and tool chains. Well, pretty much at this moment, we only have Solidity and Viper for developing smart contracts. And the tooling system also needs some it's kind of like lagging behind compared to other modern runtimes like Watson and JVM. So this effort tries to bring the LLVM to Ethereum, a developer-friendly two-chain ecosystem which is based on LLVM, that you can utilize the LLVM infrastructure. And because we believe that LLVM will be there for a long period of time, because it's been there for almost 20 years. And if you want to do your development and do some future-proof stuff, you'd better base your development on some really solid foundation, software foundation. Today, we think that LLVM is one of their candidates. Of course, LLVM has a lot of performance optimizations. It can do a lot of optimizations, do a lot of analysis, verification, etc. So you can do this, like you can utilize the LLVM tools in the LLVM ecosystem to try to improve your smart contracts performance and gas consumptions, try to improve their security, and it opens up a lot of opportunities for the developers. So impacts to the blockchain. So of course, the immediate impact would be there would be more programming languages possible, because we have a lot of programming languages. They have already built their foundations on LLVM. So if we add LLVM backend, then it makes those front ends possible to makes the developers possible to generate their smart contracts, write their smart contracts in their own their favorite languages like Rust or Golang, C, C++, and then lower them into a smart contract. Of course, like I said, a lot of developers' tools are immediately available. You can utilize them for your development. And I think one of the important things is that LLVM committee is committed to this community is committed to the long-term support of the LLVM. And I think you will find a lot of helpful guidance and advices and support from the big LLVM community. So it's a huge gain for the blockchain world, especially the Ethereum. So let's say today you base your development on the EVM LLVM 2-chain. What can you get? Of course, you get strong and mature support from the industrial level quality code, and like thousands of people are support on the online community. We're also committed to support current and future EVM versions. Of course, this makes the migration of your smart contracts to Ethereum Classic more efficiently and easily. And because we believe that the next generation execution engine is possibly, the compiler for that engine will be possibly based on LLVM. So we think that the migration to the next engine, the next generation execution engine on the blockchain will be easier as well. So what can EVM LLVM be used for? So LLVM is designed to be libraries components, like they integrate around these very core ideas of LLVM IR, and there are a lot of components in the LLVM project. So you can use the EVM LLVM as standalone smart contract compilers for the EVM architecture, and also you can use it as a library components for your own SDK. You can use it as a static analyzer, use it as a verifier. You can use this infrastructure to do assembler, disassembler, etc. So I think everybody wants to know, like, what is the status of the project right now. So we are pretty close to release an alpha version of it, so everybody can use it. At this moment, we are busy collaborating with Second State. They have this fantastic SOL front end that we can utilize to work on the LLVM-based Solidity compiler pipeline. So we also want to involve the developer communities to try to contribute to this EVM LLVM project and give some advices and perhaps use them perhaps use it. Okay, here are some of the engineering details. So EVM LLVM is based on LLVM top-up tree. We could, with a little bit effort, we could backport it to LLVM 8 or LLVM 9, which is just released. That does not take a lot of effort. We could, I think, if the users want a more stable version, we'll probably spend 1 or 2 days to backport the EVM LLVM back to LLVM 8 or LLVM 9, which a lot of people will think that is more secure. The other thing is that LLVM at this moment does not have this 256-bit support. So the first thing we need to do is to add 256-bit support in the LLVM infrastructure. So a lot of the question I got these days are that, so let's say you have a 16-bit integer and they have a 256-bit integer. Like, what does the LLVM compiler do if you add them together? The answer is actually language specific. So in LLVM, we basically specify that, well, the front end tells the LLVM that, oh, this is how it works. If the language supports the extension of the integer, it's actually being extended to 256-bit, and you do the additions on as two 256-bit integers, but automatically, like if those data types are narrower than 256-bit, we actually expand it to 256-bit. And we execute on the EVM because EVM only supports 256-bit. And there are a lot of EVM-specific operations like get a block hash, call data size. Those opcodes are exposed to the front end as intrinsics. So if you want to write your front end, you'd better expose them. Sorry, technical difficulties. Yeah. Okay, you have to expose those things. You can utilize those intrinsics to generate your EVM-specific opcodes. And I think some people know that the LLVM is designed for the traditional hardware architectures. So at this moment, there is no step machines around. And the only step machine around here are actually virtual machines, virtual instructions. EVM is part of them. So because everything in LLVM is actually done in the register-based representation. So when we are generating EVM code, we have to use a stackifier. We basically convert those register-based opcodes into step opcodes. And even LLVM is actually open source from the very beginning. We kept it with pretty low profile. We think that we want to do some work until we reach a critical mass, and then we can tell everybody that this is kind of like near usable tools that please help to support and please help to improve on it. So of course, like if you want to use another compiler infrastructure, you want to have your smart contract optimized for gas efficiencies. We actually reserve some of the slots in the backend that later on we can add those optimizations. Noticeably, like I think there's a step manipulation scheduler which will reduce the step manipulation overheads of the step machine, and there's some gas consumption optimizations passes that have been planned to be implemented to further reduce the gas consumption of the smart contract. And we rely on the front ends to generate contract APIs for deployment. And we are planning to be compatible with the existing tools like Truthfuls and etc. So a sneak peek. So you can go to ETC Labs core, find the EVM_LLVM project today. It's been there for a while. And you can take a look at the code. And I'm going to update the wiki to have more details on how to compile and use it as a backend. So let me try to let me try to try to do a little bit coding here to show how LLVM is working at this moment. So you can see that we have this test.ll file, which is generated by the SOL front end. It's the it contains the subset of the ERC20 token standard. So you can see that here is so here is the solidity.main function, which is the main entrance of the smart contract. And then we have this add and subtract safe mask here, and then we have this balance and transfer function here. So let me. So we can do C to generate the assembly code here. So to generate the SD, so you can see that we have this assembly code being generated. So those are generated assembly code. You can also generate the assembly object file. At this moment, we are using the ELF format to contain the EVM binary code. But we are planning to use an EVM-specific container to contain this binary code. So you can specify as an object. So it's pretty dark here. So you can see that there's a test.o file generated. So you can use LLVM object DOM, and you specify that this is there's a EVM-specific ELF object file, and you can disassemble it. Yeah. So you can see that those are generated codes of the EVM LLVM backend. Okay, I think that's the presentation so far. Thank you. Questions?
Make them quick.
Soon, pretty soon.
I'm just wondering how big the code is compared to like just compiling from Solidity naturally.
Can you repeat the question again?
What's the code size like compared to Sol C output?
Okay, so at the moment now we did not enable the optimization yet. So I think because it's the alpha version, so we are going to enable the optimization later once we feel it's ready.
Okay, so like, what do you expect? Just ballpark, just because I don't know how these things compare.
This compared to Solidity, I think specs, to be honest, I don't know because I don't have first-hand material.
I mean, I would expect it to be comparable because LLVM is an incredibly mature tooling.
Well, it takes time to get past the Solidity, but I think eventually we could have a better chance to beat Solidity compiler.
Oh, wow.
Yeah.
Cool.
So I'm afraid we don't have any time for more questions. Thank you very much.
Thank you.
So dinner is being, the lunch is